In this particular lecture, we're going to look at acceleration, what it means, and a few different ways to calculate it. And we'll also encounter the second of our mandatory formulas. So we mentioned previously that acceleration is a change in velocity. Remember, velocity is a vector quantity, so is acceleration, so it has both a size and a direction. Therefore, if something's moving, and if it changes one of those things, either the size, so the speed it's going, or the direction, so it turns, then it is accelerating. So we're going to look at how to calculate acceleration and what it all means now. The simplest way to calculate acceleration is by looking at it as a change in velocity over a certain amount of time. So we're going to look at an example of a car here. So we're saying, at the start of our time measurement, this car has 0 meters per second velocity. It's not moving at all. And I'm going to say it's got an acceleration of 2 meters per second squared. And we'll see what that means now. If our car travels for 1 second, by the time it has travelled 1 second, its speed will have increased by 2 meters per second. That's what the acceleration tells us. So after 1 second, it won't be travelling at 0 meters per second anymore, it'll be travelling at 2 meters per second. As the next second passes and the car travels along, after 2 seconds, its speed will increase again by another 2 meters per second, and our car will be now travelling at 4 meters per second. If we carry on and the car travels for its final second, the velocity will increase by the same jump again. Therefore, our final speed will be 6 meters per second. So when we see this unit here, this is the unit of acceleration, meters per second squared, that means the velocity of this car will increase by 2 meters per second every second. So if you like, it's a meters per second, which we write as meters per second squared. So we're now going to look at how this all comes together in a formula. This is another formula that we have to know for this course. So we're going to use the formula triangle again, same method as before. I'll just tell you what all the symbols mean. So similarly, in the previous equation, the lowercase t stands for time. Our A stands for acceleration. And this whole thing at the top represents change in velocity. So we have two terms in there. We have our initial velocity, which is the velocity you started with, and we have final velocity, which is the velocity you finished with. And that whole thing at the top links with the word equation we had before, which is change in velocity over time. So now we're going to put that formula to use using the car example that I went through before. So this is how that question might look in a test. A car accelerates from rest to 6 meters per second in 3 seconds. Calculate its acceleration. So the first thing I would do is I would look at my formula and see what I'm going to use. I need to calculate acceleration. So just like before with the formula triangle, we will cover up the variable that we need to calculate. So we cover up A, and we can see that we need to do V minus U divided by t. So then we'll go back to our question. One good habit I always get into as well before I do any calculation is I write down all the variables, just so I can keep track of the numbers. We don't know the acceleration, that's what it wants us to calculate. V was final velocity, so we know that was 6 meters per second. U was initial velocity, well it says at rest, that implies it wasn't moving, so 0 meters per second, and the time from the question is 3 seconds. This makes it really easy to put the numbers, or substitute the numbers into our equation. So acceleration equals V minus U over t. We know V was 6 meters per second, we know U was 0 meters per second, and we know that our time was 3 seconds, so that gives us 6 minus 0, which is 6, divided by 3, which gives us 2 meters per second squared acceleration. So that's how it works mathematically, and if we go back to our car example, you'll remember that I told you in the first place that the acceleration was 2 meters per second, so it all works out quite nicely.